Stay-at-home festival science stage from Cosmic Shambles. Now, the great thing I should tell you right at the start, as any of you who may be paying attention on Twitter or Facebook, is that this is a tech run. And some of you who might either follow me or Brian Cox will know that in the last 20 minutes, Brian's been kind of mocking me because I don't know how to use technology. Anyway, suffice to say, he's the only one who can't get his technology to work. So what we're going to do is we're going to try and get hold of Brian about halfway through this show. He is on the other end of something, some tin can and string thing, and then we're going to try and get in contact. But we are joined by fantastic from University College London, Helen Czerski from the Natural History Museum, Miranda Lowe, and we've got so many brilliant questions. Before we start the questions, what we thought we would do, by the way, the youngest person who sent a question, 2 years and 9 months. So we will definitely get to that question. I don't know the oldest person's question. Someone didn't send a question. They have sent a theory about why they believe the Big Bang is wrong, but I'm afraid I'm not going to be able to read out all 7,000 words of that. So we'll deal with that on another episode. I'll just start off very briefly. I'm not a scientist, so I don't have anything great to show and tell. So the only thing I was going to show is my favourite music box. This was my grandmother's music box. This is my show and tell. And why is it so brilliant? It's a very simple, quite kind of cheap music box, but now, can you name that tune?
Is that not the ice cream van?
It can be used for an ice cream van as well. It can be used by child catchers, all manner of things from Chitty Chitty Bang Bang. And what did the Swiss invent? The cuckoo clock. It's the Harry Lime theme from Third Man. That is all I was going to show and tell today. Let's start off with
it does look like it needed a little rotating ballerina or something on it.
Yeah.
You know, looking very bored. They always look so bored. I'm sure real ballerinas aren't.
I took the rotating ballerina off because it's my rotating ballerina. I don't want anyone else to see. No, I will probably. I'll work on that. The next show and tell will be the sellotape rotating ballerina. Helen, you've gone through your archives. I mean, you've done an enormous amount of exploration and events. What have you chosen today to show and tell?
So I have bookshelves which are overloaded, and I choose to overload them even more by adding things like this to them. And it's these two things, and I'm going to turn them around really slowly. Now, the important thing about these is that they started off as normal expanded polystyrene cups of the sort that have gone terribly out of fashion for very good reason. But what oceanographers have a habit of doing is when you get an expanded polystyrene cup, you take it to sea, you draw all over the side of it, and then you put it in a net and you send it down to the bottom of the ocean on a measuring device that measures temperature and salinity and all kinds of things. And this is quite standard. So the ships, you know, they basically dangle something over the side on a gigantic bit of string, and the pressure in the depths of the ocean shrinks the expanded polystyrene. So it's not expanded anymore. And you get these lovely little cups here. This is let's have this. This is a smaller one. So this, and you write on it. So I've written on it, Southern Ocean, 2012, 53 degrees south, 30 degrees west, and it's got a fish and an octopus. I'm not an artist, that's my best attempt of an octopus. These are great fun, and it's a really satisfying game. I mean, this one it's also got the depth on it. It's been down to 2,000 meters into the ocean, and they're lovely little, so we've all got them. Every oceanographer who's been to sea there's always at some point someone goes, bring your cups, we'll put them in the net and send them all down. But it is a reminder of how alien the deep ocean is, that you don't actually have to go very deep, but the pressure goes up so much, which is why things like, you know, giant squid, when you bring them to the surface, they quite often don't survive very well. It's because they're used to being squished under pressure, and then when you release the pressure, bits of them explode sometimes, which isn't not very nice. So I've got a little collection of these, so I thought that's my show and tell.
Oh, that's interesting, actually, because Marnie, who is, I think, Marnie, you're 8 years old. I think you're 8. I apologise if I've got that age wrong. But one of Marnie's questions was almost the other way round. Why is it that, what happens to a fish if it goes too deep in the water? Does it get crushed? Or is it more often the alternative, which is anything that rises too high?
So it depends on the type of fish. Oh, so we'll do fish first and then whales, because a whale is not a fish, but it does do something very interesting. So most fish, so there are a group of fish that have a swim bladder, which is an air-filled little compartment inside them. And as they rise up and down in the water column, that air compartment basically can't withstand the pressure. So that is likely to, the amount of gas in it will expand, or, you know, you get more, the fish can, now Miranda's the biologist here, she might correct me.
You're doing fine.
But so the fish can fill it up if it needs to, but often when it's coming to the surface very quickly, the gas expands and that gas actually escapes out of the gills of the fish. And I remember years ago, there was a paper that I read, and it was a very stuffy paper. It was clearly written by someone who spent their time in a leather armchair thinking thoughts about the ocean. And they wrote bubbles in the ocean, because obviously I study bubbles. Bubbles come from methane seeps, breaking waves, and the belchings of fish. And I looked at that and went, what idiot is this in his leather armchair who has said the belchings of fish? And 2 years later, I was diving off a reef, and a meter long tarpon, which is a big fish, swam past me belching out of its gills because it had come up, it's got a swim bladder, the gas had to escape. So there are fish like that where the amount of gas inside them actually changes as they go up and down. And what the fish does is it uses that to keep its buoyancy right, because fish in general, most of the fish is heavier than water. So that gas bubble acts as sort of a life jacket on the inside a little bit for some fish. And so the fish can adjust the amount of gas in it to stay buoyant. So when it comes up to the surface, it has to let some gas go, because otherwise it'll be too buoyant and it'll float up to the surface and get the bends. And the other thing I was to say is about whales, which are super cool, because a whale has lungs like ours, very similar to ours. And obviously they breathe at the surface. So they take in a deep breath, but they don't actually hold it in their lungs the way we do. When a whale goes down and dives down, the oxygen is actually stored in its muscles. And the reason for that is its lungs are going to get crushed. It's going to squeeze all the oxygen, like the pressure of the oxygen would go up and go out into the bloodstream and actually damage the whale. So what the whale does is it shuts off the connection between its lungs and the rest of its body. And when it's underwater, it's breathing entirely from oxygen stored in its muscles, which is completely different to what you might imagine. So I've forgotten the original question, but there's lots of interesting things.
Hopefully, Marnie, I think, will have enjoyed that answer. When you were talking about that, it reminded me of someone once after an event we did coming up and saying, I thought your introduction to Helen Czerski was extremely sexist. I said, sorry, what? Why you described her as a bubbly physicist? Would you introduce Brian Cox as a bubbly physicist? I said, no, I said, she's a bubble physicist. She went, oh, I'm so sorry. So anyway,
but he does quite like his champagne, Brian. He does have his bubbly physicist moments, right?
Yeah.
You do know this.
The Miranda, you are, I mean, you work at the Natural History Museum. I imagine you have access to those wonderful storerooms as well. Which
millions of specimens and creatures from under the sea, things that live on land. Yeah, it satisfies my curiosity. I'm the curious curator.
Did you have when you first had access to that, and you are kind of, I'm not going to say running wild, because obviously you're very, very careful with what you do and wear gloves, if any, but, as wild as you can be as a curious curator, what was the thing you were most excited to see?
Oh, gosh. I fought for choice. When I first got my job, they took me down to what was called at the time dry storeroom number 1. So when I went in there, it was just an amazing, it literally was a cabinet of curiosities. Lots of taxidermy, zebras, the stuffed giraffes. There were corals in cabinets. You name it, it was in there basically. But what I like about my own collection are the king crabs, so the deep ocean crabs. Not quite the Japanese spider crab. We've got 1 or 2 of those around the museum. Well, one was in the Creepy Crawlies gallery, but within my own personal collection, we've got a lot of the king crabs. So they're Lithodes crabs, and they have legs that can span up to 6 feet. I mean, really amazing to see those deep sea, as Helen could appreciate, those deep sea creatures, to see them up close and personal is the most amazing thing.
And so I was going to say that I've been lucky enough to go on a tour of the Natural History Museum stores, and the weird thing is that you open cupboards, and the cupboard doors are all solid wood, and you open them, and they're these things, and you don't know whether it's going to be a monkey or a shrimp.
Well, that's it. That's the diversity, and that's the most amazing thing. When I think I've seen it all, I just open a cupboard door and I think, oh my God, this is amazing. And I look around the store, and there's actually no one else in there but me. But now, through the medium of Twitter, I can just share those really amazing moments to everyone, like what we're doing now.
That's what I love. I've been lucky to go back to, like, there's the one at Trinity College, Dublin.
Oh, yes, I've been there as well.
That's got those great things which are the bits that got lost. So yeah, unfortunately it's a brilliant giraffe skeleton, but the head got lost in the post, you know, that kind of thing. Or there's one in Cambridge where I was going around and they went, I'll show you something about Charles Darwin. He did not know how to pack eggs, and the egg samples that he sent back, he would pack them too tightly. So go, see, that's another broken egg that's no good to us. Thank you, Charles Darwin.
His handwriting was rubbish. So I think, and again, Miranda can correct me, in the Natural History Museum, they've got all these samples that came, the voyage of the Beagle, but they think it's somebody else's handwriting because his was so bad.
Wasn't great. I mean, I look after Darwin's barnacles, and get samples of his handwriting. You know, miraculously, a lot of that has survived because he had that huge collection sent to Down House. So he was able to, you know, in the luxuries of his own front room. See, we're all doing this from our own front rooms now at the moment. He was able to just study the barnacle collection obsessively for 8 years. So, you know.
We've all become Victorian gentlemen scientists.
We have.
I love that. When I was studying, I did a show which had a load of stuff about Darwin. I talked to the wonderful Steve Jones, who wrote Almost Like a Whale and others. And I said to Steve, I said, is there any Darwin I shouldn't read? And he said, don't read his books about barnacles. He became overly obsessed. And I thought...
But, you know, I benefit with that. Maybe I've become overly obsessed with them too, because I look after them, and, you know, all his kind of like notes that he's written. And it's just an amazing thing to actually handle these things that he actually physically touched and was dissecting. It's the most amazing thing in the world. Almost Like a Whale, yes.
It is a fantastic book. Steve Jones is a wonderful writer. Miranda, we haven't yet.
I like the idea. Sorry, is that Miranda is like the picture of Dorian Gray for barnacle obsession. Is that Robin and I, every time we might have a bit of barnacle obsession, it actually just accumulates in Miranda. She has everyone's. She's accumulating all the barnacles.
100 times more.
So your show and tell, Miranda, is it barnacles? Is it shrimps? Is it a monkey?
Well, close. It's related to shrimps. I hope everyone can see this. So this is a woodlouse. It's not a real one. It's actually from a birthday cake some years ago. As you do, you have a birthday cake that actually has the icing on top of the cake. It's made out of your favourite animals. And so one of my favourite things are woodlice, which are related to crabs, shrimps and lobsters and barnacles, of course. So crustaceans. So this is an exact replica of a woodlice that has 14 legs. So scientifically, we class woodlice as isopods. So that means equal feet. So it has 7 on one side of legs and 7 on the other, and 2 antennae. And then at the back, I'm hoping everyone can see this. I'm going to point to it with the pencil there. We have what we call the pleopods at the back. And that's where woodlice can do what we call drinking through their bottoms. Yes, like a straw. Does everybody remember capillary action? So yes, that's what they can do. They actually smell with their antennae. So you can see the antennae at the front here. Oh, I'm pointing in the right. Yeah, there we go. Yeah, and they like to eat decomposing leaf litter. They can sense the different types of bacteria on the decomposition there, and also rotting wood. So that's why you usually find them on a decaying log, or, and because we're all sort of isolated at home at the moment, but if you're lucky enough to have a back garden as well, you can go outside, look under your logs or under your flower pots, and you can find these lovely things. So they like damp, wet areas, and they usually sort of scurry about in the night, so they're nocturnal as well. But there you go. But this is a bit of icing that I didn't eat.
That's beautiful, though, because that's another reminder, which is, going back to Darwin, his book about earthworms, which I used to read out from on stage. It's such a beautiful book, the formation of vegetable mold through the action of worms with observation on their habits. And it's my favourite bit is where I can't remember which of his sons he made play the bassoon to an earthworm to see how they might react to various different kind of auditory experience. But that great thing that they're talking about, the woodlouse, is all of these things that we can very often think of as mundane, the earthworm, the woodlouse, those things that might just be, dotted around a small garden, in a park, whatever. As you just said, they're from the drinking from the bottom to the number of legs to all of that. It's still, everything is fascinating.
It's really amazing. Never think woodlice are boring, because there are about 39 to 40 different species in the UK alone, and we have things that have different body forms. So they have things like clingers, rollers. So most people might recognise woodlice that roll into a ball. So their common name are pillbugs. So you'll see those. So what have we got? We've got the clingers, the runners, and the rollers. It sounds like an episode of
Seven
The
Dwarfs. and there was the one you've got there is quite large, right? Quite a horrifying size if you don't like.
I know.
But in history,
it's 9 centimeters, but they're usually not that big.
But in history, there have been crustaceans that are that big, right? And much bigger.
Well, we have the ocean or the sea version of the woodlice, the sea slater, so which is quite big actually. They're cousins. Ligia oceanica. That's what we've got. Yeah. But yes.
That's brilliant. Thank you so much. Now, we're going to come back to both of you with the questions. In a moment, we're going to go over to Matt Watson, a wonderful singer-songwriter I've done various gigs with in the past, who is going to sing. Because originally, one of the reasons we're doing this was we were all meant to be at the Cutty Sark today, doing an event about the oceans. And then this is what we're trying to do instead. And I hope you watching it. I hope you enjoy it. Hopefully, we're going to ask some of the questions you've sent in as well. Also, just quickly mention, we have on our page a kind of tip section that if you want to leave any money, and what we're trying to do is basically we're trying to raise money for people in particularly kind of performing arts who, having had all of their work removed for the next 3 months, may well be struggling. So it's not to some of us are lucky and we have other ways in the performing arts that we're able to make money, and we're doing okay. But for some people playing the small clubs, whether they're musicians, whether they're poets, whether they're comedians, whatever it might be, that's all they have, and it's going to hit them hard. And we're also going to try and give some money as well to some of the venues, some of the small arts venues that again may well have to basically get rid of those people who work for them and may well not arrive again. So we are hoping, I've just seen a little message on my screen, by the way, which says that Brian might be having a little bit of trouble with his broadband. So while there's trouble with his broadband, why not let's go to a one-man band? Yes, I segued. Look at that segue. This is totally unscripted. Please use me, local radio. I am available. We're going to go for a song with the brilliant Matt Watson. So, ladies and gentlemen, here he is.
Hello there, how you doing? This is called Outside. White-tailed horses greet the land of the trees, they talk to me. I hear whispers through the leaves, branches reaching out to breathe, but they don't know where I'm from. They can't hear me to them. I'm gone, I'm outside. Where I'm from, they can't see me to them. I'm gone, I'll be outside, looking in the sky, it makes me cry. An eagle flies out of sight, but a fire wing brings from the light and the rain. Yeah, the rain, it follows me. It cleans away the dirty earth, brings life, hope, death and birth, but they don't know where I'm from. They can't hear me, to them I'm gone. I'm on the outside. They don't know where I'm from. They can't see me, to them I'm gone. I'm on the outside, looking in. Here I am, stuck between worlds where I'll forever be. Places I have known, yeah, the distance I have grown. Nothing but distant memories. Here I'll drift alone on ocean breeze. The mountains and the city streets are where I make my home. And they don't know where I'm from. They can't hear me, to them I'm gone. I'm on the outside looking in. And they don't know who I am. They can't see me, to them I'm gone. I'm on the outside looking in. And they don't know where I'm from. They can't hear me, to them I'm gone. I'm on the outside looking in. To them I am gone. 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 I'm on the outside. On the outside. On the outside. On the outside. To them I am gone. To them I am gone. To them. Well, thank you very much in this surreal way of doing a gig.
Thanks so much. Matt's going to be back shortly. We'll be talking to him again. I've just spoken to Brian. We are still trying to work out. I think it may well be a tech issue his side, but we're still trying to get hold of him. I might just give him a call and we'll put him over loudspeaker for some of the questions about black holes. But I'm certain that Helen and Miranda will be able to deal with all of those questions. Man, I had so much fun. I was the other day I was doing a podcast with Ed Miliband and Jeff Lloyd, and Ed asked me, he said, what's your favorite thing that's kind of been observed astronomically in the last few years? And of course it is, getting that image of a black hole. And they said, what is a black hole? And I started to explain the idea of density and gravity. And when you just, and of course I'm not a scientist, so of course it was reasonably cack-handed and all over the shop, but hopefully underneath it all it was kind of it was comprehensible. But just seeing someone's face when you start talking about that, and they just, because the universe is so big and some of it is so mighty and I'm terrified. It was wonderful. So I'm going to rattle through these questions, and I'll save some of the physics questions for Brian. This is actually for both of you. I'll start off with you, Helen, and then I'll come to you. But this is from Rory, who's 4 years old, and he wants to know: do you think we will ever live on the moon?
I think that we in general as a whole civilization will not. So I tend to be, I always sound slightly grumpy about this because everyone else is like, yes, we're going to go to the moon. And I quite like Earth. Like Earth is our life support system in space. It's our, it carries us around. It's got everything we need. And I would like us to spend a bit more time looking after this one. So living on the moon, is technically possible. It's expensive. There might be some advantages, but fundamentally, what if you actually look at the Apollo missions? People went to the moon and they looked back at Earth. And I still think for all the adventure of Apollo and all the amazing technological human achievement to go to the moon, The thing that happened was that people looked back at Earth. So I am not convinced that anyone is really going to want to live on the moon, unless they're doing really, really well at this whole social isolate. Maybe what this is just a test for the first moon astronaut. If you're really good at this, then you can go to the moon. But I honestly think you go to the moon and what you see is how beautiful our own planet is. So maybe you could, but I honestly don't think you'd want to.
I think that's a good. When we had Rusty Schweikart on, because Apollo astronaut, who when he was on the Infinite Monkey Cage, when we asked him, what was the most important thing from the Apollo missions, he said exactly that. He said the most important thing was not a human being standing on the moon. The most important thing was probably that image, I think, taken by Apollo 8, as far as I remember, Earthrise.
Bill Anders. Yeah, Christmas Eve, 1969, was it? No, yeah. So sometime, no, 1968.
1968, yeah.
Yeah. It's hard for us to appreciate now what a big world. I mean, all of the generations of humans that had lived on this planet, and the globes, people had globes in their living rooms, posh people, and they were all deduction. They were all maths had, said, oh, it must look like this because the measurements do this. And then you go out and you look back and it did look like this. And that's a mind-blowing change in literally your worldview. And I think it's hard to underestimate that now.
Miranda, we had a question which I think kind of follows up from that. Just talking about the idea of living on the moon. We had I've lost her name now, but she wanted to know. I know she was 10 years old. She wanted to know how long and how deep could people live in. How deep can you go into the ocean? Was her and live for any reasonable amount of time? So if you were actually able to have, so where could humans comfortably live inside? Well, I say comfortably, but survive within a.
I think Helen's got more experience about that with the deeper depth of taking submersibles down there. I mean, we've got so many animals that have adapted to actually live in the deep, dark ocean. I mean, our technical equipment, divers can only go down so far, and when we're doing deep ocean research, we're not actually diving down there. It's now, it's equipment, and the equipment is getting better now to go down there, doing a lot of filming. Even if you're sampling from the deep ocean and bringing up certain animals to the surface, unfortunately they're not likely to survive. I mean, Helen, what do you think? What's the I really, well, technology's moving on, but I really couldn't see, in terms of.
No, people have tried. I mean, the submersibles still do go down. They make a lot of dives still. And actually, I interviewed someone, a scientist in Seattle recently, who's done a lot of dives, and she said time passes so quickly because even though it looks like the deep ocean, there's not much there. There's so much to look at, and there's mountains and valleys and all this stuff.
Yeah,
and she said time passes very quickly. There. So if you put people in that kind of bubble, like Alvin, that's the most famous submersible. You can put people down there and you can live down there. But again, the question is, do you want to stay down there? And people have done this experiment. So there have been attempts at living undersea for long periods of time. Even now, I think off Florida, there are underwater labs where you can go and live in that lab and then you can come out and dive. And the reason for doing that is that as you go underwater, you breathe, because your lungs, if you don't want your lungs to collapse, you need to give your lungs a chance to fight back against all the pressure I was talking about earlier. So you have to breathe gas at a higher pressure. And that means that you're breathing more gas because you have to put more in order to create that pressure. And that means that you get extra nitrogen in your blood. And that doesn't do you any harm as long as you don't increase or decrease the level really quickly, especially decreasing it. So if you go and live in one of these undersea habitats and you're already at 300 meters or whatever it is, probably not that deep, you can go out and dive and come back in and go out again without having to do all the stages of letting your body get used to changing nitrogen levels. So people have tried doing things like that, and it is a way of working, and it's used, for example, for underwater archaeology even, because if you're right next to a site, you don't want it to take an hour and a half for your divers to get down to the archaeological site and an hour and a half to get back up. So you let them live down there in a little bubble. So you can live underwater, but it does take a lot of effort. And it's generally better, as Miranda says, if you're doing large surveys, better to send the robots for the really deep depths.
Yeah, because there is for diving, there's a lot of physical, stress on the body, and so you do have to, each time you're going diving, you have to be physically fit, and so over time, in terms of going out of that little bubble, it's going to take its toll on us as humans. So I don't think it will happen. A lot of the deep sea animals that live deep in the ocean also cope by having this what we call gigantism. So Helen, actually, I was talking to you earlier on when you were alluding to a deeper woodlouse in the ocean, and I mentioned the Lygia, but the deepest one is Bathynomus giganticus, so a massive deep sea woodlouse that can be the ones that I've got in the collection, they're about 30 centimeters long, if not more, and they are huge, and so that is an animal that has that kind of like body structure coping mechanism, that it's so big. A lot of the deep ocean, like Japanese spider crabs, have really long limbs. The deeper you go in the ocean, that you need more capacity for oxygen, and they have, so they're known also as extremophiles, that are able to live and so deep and cope with those kind of pressures. But also it's darker as you go deeper into the ocean as well, so the light intensity is less, and so a lot of these animals also adapt in the way that they will have either larger eyes, such as Bathynomus, or longer sensory organs, antennae, or the legs, to help them feel and sense things in the dark, essentially.
Because of course that's the other reason you might want to live in the ocean, is that light doesn't travel very far. So what you need is to be able to see in sound, because that's the way information really travels across the ocean, in sound. If you want to find out something, use sonar. And so I think humans might be a lot more interested in the ocean if they could see and sound the way that a dolphin does. And we have got the technology to do that. There are divers that have they have a sonar on their chest that's looking out, and goggles that show them the sonar image. It does exist. But I think a bit more of that might make it a bit more useful for humans a bit more interesting for humans to live underwater.
Right, well, we move to the next question, because you just mentioned dolphins, and Blythe, who is from just outside Sydney in Australia, she's been reading about the work of John C. Lilly. So this is for you, Miranda. Some people know John C. Lilly became, as well as becoming reasonably obsessed with the possibility that hallucinogens were going to be something that was going to be tremendously important in our evolution as human beings. He became fascinated in the idea that we might be able to communicate with dolphins. And Blythe wondered, what do you feel about the abilities, the possible abilities for us to be able to communicate with other intelligent species on this planet?
Wow, that's a big question. But they are, from what I know, my generalist knowledge, very clever animals and communicative animals as well. And Helen working on whales as well, or whale poo anyway as well.
There's a reason for that. I don't work on whale poo, but I have been known to talk about it.
Yeah, to talk about it. I know. I'm just linking it into the larger animals there, of that kind of communication under the ocean, and that is a link, because we were talking about humans living in the deep dark oceans, how we would communicate. Sorry, Robin, I've absolutely forgotten what the train of your question was. Do I think that we can communicate in that way? What was it?
Well, just what do you have any hopes, or is it a hiding place? Because Carl Sagan, of course, talked about the fact that sometimes we say, oh, we're going to try and communicate should we manage to find extraterrestrial existence, and yet we're unable to actually communicate with the intelligent life that is on our planet. Yeah. So if something which has developed in an entirely different kind of environment,
could we well, it is a really big question. I think there is, there's potential there, and there's a lot of speculation around it. I mean, it's a bit like we were talking about, well, could we all go to the moon and live there on other planets as well? I think that is possible, but from my personal perspective, I think we've got a long time coming for that kind of thing. Yeah.
An interesting analogy might be dogs, right? Because the you can communicate with a dolphin. You know, dolphins recognize, they have a call that
they have their own
recognize.
specific calls, yes, and the same with dogs. It's also making me think of I can't remember what it's actually called, but do you know that device that only the young people can hear?
The
if
dog
they are
whistle,
hanging,
the really high
that
frequency,
is dog whistle effect, and that's linked to age as well.
Maybe the dogs are talking to the dolphins. That's what's going on.
Yeah, that
they just haven't told us.
Now, there is one of the chapters that Douglas Adams never got round to. So this is, we're going to try and many questions. Okay. Now, this one, Helen, you might know, but I think you probably will be okay on this, but it's not it's physics, but not necessarily where you concentrate. Polly, age 7. First of all, she says hello. Hello, Polly. I hope you're still watching. She would like to know, how far away is the nearest black hole and what might be on the other side of one, which is always an intriguing what people...
You are right. This is not quite. I do the physics of the.
Wrong.
That is a question for Chris Lintop. I don't know the statistics. Sorry.
No.
I think it's a lot of them. I mean, that my impression is certainly that it's a lot of them, because that's where you notice the difference between. That was one of the sources of the question about dark matter, right? Because the speed at which galaxies are rotating around can't be accounted for by the black hole in the middle, which that's maybe not related. But the point is, you could measure the mass at the middle, and it didn't account for all the gravity that seemed to be, in there. So I don't know is the answer to that question. What's on the other side of one? So black holes. So this is where you get into, general relativity, which all gets a bit sort of messes with your head quite a lot. But black holes, mass and time sort of and space interact with each other. That's what a black hole does. So it's actually the black hole sits within space, but it's also changing the space around it. So on the other side of a black hole, it is just more space. There's nothing different if you go around the back of it, but you can't go through the black hole, because the reason they're called black is that they have an event horizon, which means that if you get too close to a black hole, you basically can't come out. So if you do want to go around around the back of a black hole, you have to go the long way round in order. You can't go through. There's no sort of bypass through the center of a black hole, but it's space in the same way that we see here. So one of the things we do see about space is that as it's expanding, it's expanding equally in all directions. So it's not like there's you don't get closer to the edge if you go to the other side of a black hole. I don't know if that helps or not.
So I suppose, is it also because the black hole sometimes, I think was it John Wheeler who originally coined it? I can't be so sure, but is the fact that the hole is really the top bit that you fall into. It's not the bit at the bottom. The bottom is something of incredible density from which nothing can escape. It's not as if you then go, whoa, there's a hole, and I've just met the time bandits. This is fantastic. Yeah. It's not. Is that because I think that's why a lot of people would imagine, but I might be wrong about that as well. After all, I'm an arts graduate.
It's not like a well. But the thing is that as you got, assuming you could survive crossing the event horizon, if you had a physical body at this point, it would be very spaghettified. But assuming that wasn't the case, all you would notice is to an outsider, it would look like time was slowing down for you. So your perception of time changes as you get into a black hole. So if you were inside one, you might not necessarily know that, but you wouldn't be able to come out again. But then time would be passing so slowly that you might not appreciate that.
Well, the good thing is this time next week we've got Brian Green on as well as Brian Cox, so we'll go through more about black holes there. I've got one more question, then we'll go back to Matt, and then we're going to try one more time to get hold of Brian. It's another one from Marnie actually, and hello again, Marnie. And this is about narwhals and their big tusks, and she wants to know. She's 7 years old. Are they likely to sometimes accidentally spear other fish as they go through the sea?
I think that's a curious question that I've never thought of also myself, but yeah.
They're a tooth. So the tusk of a narwhal is actually a tooth. And you do get occasional narwhals where they've got both. So it's the left one. So they've got this tooth that sticks out, but they could have both. And so I have seen narwhal skeletons where this narwhal went through life with 2 of them, which is even more inconvenient, and especially for not spearing your friends or your enemies. Maybe it's got its uses, but they are quite good. I think they have sensing, they have sensing capabilities, the tusks. So it's not really clear why they have them. I think it's thought that they're a, fighting sort of display. It's a sexual dominance thing, basically. Make all the jokes you want. But it tends to be the males that have them more than the females, I think.
And isn't it, Helen? It says predominantly a left-handed swirl on it, or spiral on the
they
twist.
Twist as they go, and it is a left-handed one. It's a bit like, maybe it's a bit like that question about DNA molecules. There's this thing called chirality in chemistry, and the molecules of life all twist the same way. And it's not quite as strict with the narwhals, but they do all twist to the left. What's that, Robin? There's a poem about toothbrushes, or what is it? Is it violets or something? There's like the honeysuckle to the left and the something to the right. There's an old song.
I should know about that. I'm not meant to know about black holes, but I'm meant to know about poems about violets and toothbrushes. That's one of my areas.
That is. I'll look it up while Matt's playing his song.
Right. Well, we will go over to Matt again. We have loads. We almost got Brian on the line, so we're getting closer. I should also mention that hopefully all of those. This is still a tech run. We're kind of a tech thing that we're going through at the moment to try and work out all these things. And I think this one is happening on Brian's side rather than on our side. And Brian should be with us on Tuesday as well. So any questions? There's lots of questions that I won't ask, which I'll save for him on Tuesday at 10 a.m. On Monday, we've got Mark Gatiss joining us, and also, as well as Mark Gatiss, we have George Egg doing some very strange cooking, possibly with trouser presses, amongst other things, and Grace Petrie, who will be singing as well. Just a reminder, the tip jar that we basically, the virtual tip jar at the bottom, is to try and make money for people who, performers, etc., who are going to be really up against it because they have no work over the next 3 months, and also hopefully try and support some of the art centres and venues that may well otherwise go under, and the people who work for them, to make sure they've got money as well. So thank you very much if you have a chance to do that. We are now going to go back to Matt, and then we might have Brian with us afterwards. Otherwise, in fact, we might also later on try and record something that we'll put up with Brian, so we might be able to do something that isn't live. But let's go back now to Matt Watson.
Hello. Okay, this is called Grounded. Shoulders to survive, and I can no longer look you in the eye. Tie a rope to my feet, yeah, bring me back down to earth. With insincerity, I'll never be cursed. And if you swim against the tide, you know the reward's not hard to find, as the waves bring you back in again. And you keep my feet on the feel my feet on the ground. Yeah, you keep my feet on the ground. On the ground, the ground, the ground. Head, yeah, my thoughts, they've gone to bed, so I'll get up and let you drift in instead. Cause I'm forever in debt to the heartaches and regrets, all the trouble, the joy and the pain. And I'll happily reply mistakes with different takes, yeah, they show me my future's way. And now here comes my future, and I ain't running from it, so let's take it on today. And you feel my feet on the ground. Yeah, you keep feel my feet on the ground. Yeah, Thank you very much.
Thank you. Go and check. Matthew, if you're still there, hopefully, can I just check website where people can find out about because obviously all your gigs cancelled at the moment as well, and a lot of your work is touring with people as well as playing your own stuff. Where can people find out how to get your songs and stay in contact with what you're doing?
So bandcamp.com, Matt Watson Music, and also www.mattwatsonmusic.co.uk. That's my website, and I've got everything on there, links to all my social media and everything else. So
thank you very much.
Appreciate it. Thanks for having me.
And we'll see. And we'll see Matt back again, and not today, possibly, in fact, because he's only prepared 2 songs, so they'll be a little bit out of nowhere there, but we will hopefully see him again. And, well, we definitely will. And Matt also, I should mention Bandcamp. I think they're still doing it, but if you buy music off Bandcamp, as far as I know, Bandcamp are currently not taking any percentage. It's going entirely to the artists, and Bandcamp has a lot of artists who, again, they're touring small gigs, they're doing small places, and there's sales of their music are kind of the thing that keeps them afloat. So if you get a chance, have a look there, find out about the music that's going on. Right, we're going to rattle through. We have some glimmer possibility that we're going to get through to Brian. About 5 minutes ago, we had some hope. So right, let's first of all. So we've got, these are from Oliver's daughter Alex, and her questions. We have quite a few. First of all, this is an interesting one. Why are slugs slimy? Who wants to take that one?
Oh gosh, I know a man who can. Slugs are slimy. Well, you know, that is part of, well, they're invertebrates, animals without backbones. They're generally, they don't have a shell like the snails do. So therefore, there's not that much protection in terms of stopping them from dehydrating. So that mucus is a layer that allows the body to keep moist, but also it helps them to transfer across rough surfaces on land, and also it's quite there's been some research recently of how strong that kind of slime that they produce is in terms of us. Another animal, I'm referring back to my barnacles as well, because the reason why they the encrusting barnacles stick so well onto rocks, stones on the shore and things like that, is because they also produce or secrete a cement-like sticky substance that allows them to adhere to the rocks for literally forever.
And the slugs, their slime helps them move. So it has this really interesting property, which is that it's thick and gloopy until you shove on it really hard, and then it becomes temporarily much thinner, so less viscous. And so what that means is that by controlling where it's shoving, because, how does the slug move, right? It's just got one foot, it's stuck to the surface. Yeah. How does it go anywhere? And the way it does it is by pushing with different strengths in different places. It effectively slides itself along where it's pushing fastest, but anchors itself in the bits where it's viscous, and then it moves, so it changes the viscosity of its mucus to enable it to effectively walk across the surface all on one foot. So slug slime is really interesting.
That's cool. Also, Alex, she wanted to know, this one's for you, Miranda, what's the biggest fish in the ocean? It doesn't have to be an individual one, I think, just generally a species as opposed to...
We've got basking sharks, they're really big, flying fish, rays. All of those are pretty big, and as Helen said, well, we know that the whale is the biggest in the ocean, but it's not actually a fish. But considered under the royal fishes, though, whales are.
I did look up the largest historical fish. The largest fish we ever know has lived on Earth, and it lived in England. It turns out, and you can probably say the name, Miranda. You seem to be really good at Latin names, but it's something like Leedsixthis. But it was around 21 to 27 meters long. This thing lived in the Jurassic era, but I can't say it. I need your Latin skills.
Oh gosh, I have to look at the spelling though, because I'm not familiar with that one. Oh,
anyway.
That's it. That bit of not pronouncing. When we did a monkey cage about quantum mechanics, and we were having it signed. Having it signed as well for people with hearing impairments, etc. And basically, we gave them the worst gig that they would have to sign, because of course, trying to sign a lot of terminology from quantum mechanics is it's not been dealt with as yet. This is an interesting question from Evan, who is 8 from Plymouth. Hello, Evan, if you're watching. What colour is the sun? Now, I think this is interesting because, of course, the idea is, with colour, as we know, is kind of it's a secondary property. It's something which is down to our perception and other creatures' perception of what they might consider the colour to be. But I wondered if either of you have any take in terms of what you would think of it actually, if you were able to observe it, full on. And don't go and stare at it now. But it's what do you think you would see?
So it actually depends on where you're looking from. So there's a difference. So colour, as you say, is perception. We can measure the wavelength of light, and that is a physical thing that you can measure. And then there's the thing that our brains interpret. But if you look at our sun outside our atmosphere, it looks like any other star to us. It would look white, obviously, without looking straight at it. The reason the sun looks yellow to us is that we tend to see it low on the horizon when it's, that's when it's dim enough for us to look at. And we're seeing some of the light that comes from it is scattered away as it comes through the atmosphere, and what's left tend to be the redder colours, which is why the sun gets redder and redder as it gets towards the horizon. So although we think of the sun as yellow, first of all, if you went outside our atmosphere, it definitely isn't yellow. It's white like any other star, and that's because of its temperature. It's effectively white hot. But then when we can look at it, it looks yellower and yellower as it gets dim enough for us to look at until it gets close to the horizon where it's red, because all the blue light is scattered sideways by the atmosphere, more likely to go straight through. So the sun itself doesn't have a colour, but our atmosphere gives it a colour.
Question for you, Miranda, in fact for both of you. This is from Keith, who's from Liverpool but is currently in Cairns in Australia because that's where he has to stay for the time being. Hello, Keith. This is he would like to know, would any of you now, or as your younger selves, I presume that's for me, consider going into stasis style sleep for a deep space voyage after the discovery of a new exoplanet that was habitable?
Ooh.
So it's an interesting.
Maybe as my younger self, because what I know at the moment, as my younger self, I probably would be more willing to take risks, because that seems as a risk in my older self to me. So yes, I might have done it in my younger self. Yeah.
Now you, Helen, you do go off on these adventures sometimes with a certain amount of kind of icy desolation that some would imagine. And how would you feel about the deep space, deep sleep?
Well, I've never yet gone into space yet. I think that I like this planet so much that at this point I might stay, because of course the implication is that you can't come back. The way the physics of this works is that if you go into stasis for a time period and then you have to deal with the travel to another planet, you can never come back. So it's not a question of whether you go on an adventure. It's a question of whether you would sacrifice the rest of your life in order to do it. And I think if I was towards the end of my life, I might, but at this point I wouldn't. But I should say, so there's this question about going to Mars, and the problem with going to Mars is that there's huge amounts of cosmic radiation will basically give you terminal cancer after you've been there for a very short period of time. And the astronomer royal, Martin Rees, who is a brilliant and very lovely scientist, who is just an amazing person, we did this whole thing for a program I did once about he was talking about how much he wanted to make a one-way trip to Mars. And I had just done a piece on all this radiation that will give you terminal cancer. And he came up to me, the astronomer all came up to me afterwards and tapped me on the shoulder and said, "Is it really true? Are you going to have terminal cancer by the time you get there?" And to my shame, I said yes. And I wish I hadn't, because it felt like such an awful thing to do, because he really wanted to go. So, yeah, there were a few practical problems on the way.
So you do that, Helen, at the end of your life, whereas I would do this at the beginning.
Maybe.
Yeah.
I don't know.
Yeah. Well, yeah.
Who knows? We haven't been faced with the question yet. Let's look after this planet. That's what. If you want alien worlds, go to the bottom of the ocean. I keep saying this. If you want exoplanets and alien life, go and meet an octopus. And I think that is so fascinating all by itself that you don't need alien life in other places for quite a lot until you've really discovered the ocean, all of it. Then you can worry about exoplanets.
Right, we'll get through. Sorry, Miranda. Here's this from Carl.
along hydrothermal vents, so basically volcanoes under the sea that give off a lot of hot, sulfurous, toxic, well, it would be toxic to us, water. And so these crabs have adapted. So we have the Yeti crab, which I think was a new species of Yeti crab, was discovered in 2004, 2005. I could be corrected by Twitter. And we also have the Hoff. So the Yeti crab, because its first claws or near its pincers, those parts of its body, so in relation it would be our arms, they're all really hairy. And then we got the second species that was found, was nicknamed the Hoff. And after those of us that remembered Baywatch, David Hasselhoff and the hairy chest. So they have a hairy abdomen or tummy. And on those hairs, they have chemosynthetic bacteria that can actually utilize the sulfur that is given off from living alongside these hydrothermal vents. So I think these, and there's a third species that has just been discovered as well as those crabs, and those are really amazing. Those kind of adaptations to live alongside something so hot and toxic in the deep ocean. And the hydrothermal vents themselves were only discovered in the 1970s. I say only. I know time's moving on, but you know, it's relatively recent times.
I've got one more question, which is for both of you. This is from, I hope this, I think it's Avaria.
Have we got Brian now? Is that really
we may well have Brian. We may well have Brian as well.
I think it is, but only on the phone. So it's,
okay. A quick couple of questions with Brian as well. But in fact, Brian, this is your first question. Avaria, who's 2 years and 9 months old, would like to know, why do we need to eat all our dinner?
That's a medical question. I'll pass that back to my colleagues.
Well, then the other one from Avaria, 2 years, 9 months old, is, and this is a great, it's such a beautiful thing, again, to see that wonderful imagination at an early age. Why don't all the stars fall down?
It's a great question. I could give a long answer. How old is How old was the person who asked the question?
She's 2 years, 9 months. So I think you might, there is going to be a problem in terms of some of the equations you're going to use. And I mean, there is for me, and I'm 51 years old. But just generally, I think that's an interesting thing. What everything does see, even though it's moving at the same time as it moves, it seems to us to stay in place. And that, for some people, can seem like a counterinstinctual idea.
Yeah, I mean, there's a very famous quote, actually, and I can't remember who it's from, but it's along the lines of it. It's about Newton, and it says that it took a genius to realise that the moon is falling when any idiot can see it standing still. Right? So the point is, yes, the moon, for example, which is the closest object you can see in the sky to us, is indeed falling towards the Earth, but it's falling and missing because it's also moving in a different direction, what you might call a transverse direction. In other words, it's in orbit. And it's the same for the stars in the galaxy. So in a very real sense, the stars are falling inwards towards the centre of the galaxy in the same way that the moon's falling towards the Earth, but they're also moving in a different direction, and so they're all falling and missing. I mean, that's in a sense what an orbit is, and you could extend that to the galaxies. So nearby galaxies are gravitationally attracted to each other. So, for example, the Andromeda galaxy is falling towards the Milky Way now, and the Milky Way is falling towards the Andromeda galaxy, and they're going to interact and collide in, I think, some billion years' time. The very distant galaxies, this is why it's a great question, the very distant galaxies are actually not too distant, but more distant than Andromeda and more distant than the ones in what's called our local group that are gravitationally bound together. Then they are receding from us, and that's because of the expansion of the universe itself, which overcomes that gravitational pull between the galaxies if they're far enough away. So it's a brilliant question, and it shows great insight because you're thinking about what gravity is.
Dylan has just, you mentioned galaxies. Dylan wanted to know, how many galaxies are there that we are aware of?
The number is something like 2, give or take. And that's obviously an estimate because we haven't counted them all. But we've done very, very careful surveys of the nearby universe, something called the Sloan Digital Sky Survey. And so we know how big the part of the universe we can see is, and it's about just over 90 billion light years across. So that's the furthest we can look in every direction, just over 40, something like 42, 41.5 billion light years in every direction that we can see. And so we know the volume of the observable universe, and we know the distribution, the kind of density of galaxies in the local universe. So you can estimate, and it's something like, it was less actually. We know how much matter there is in there, and then I think that it used to be a few hundreds of billions, and it changed because we realised that there are quite a lot of smaller so-called dwarf galaxies. So you count all those, you get a number well over 1 trillion.
Brilliant. And there's one more, and then I'll open up again. But this is from Harris, who's 6 years old. Sorry, I'm doing all the questions that I would have done. We would have mixed it up a little bit more, so I apologise for the fact that we couldn't see. But 6-year-old Harris wants to know, what are the rings of Saturn made of? And I always love these questions. Of course, one of the beautiful things is it still correct in also saying we don't as yet understand why the rings of Saturn are, why they behave as they do? Is that still right, Brian, or have we moved on with that?
Yeah, so, water, ice. But one of the great mysteries is that they're very clean and shiny, which you can see if you look at it through a small telescope. You can see them. You know, they're so bright, even though Saturn's so far away. And the universe, the solar system, is full of dust. So the solar system is a place where if you leave things lying around in the solar system, they get dirty because there's a lot of dust in there. So it has been and still continues to be a unresolved question of why are the rings so bright. I think the preferred answer at the moment is that they are young, and so they haven't been around that long. So we think that likely in the time of the dinosaurs, certainly the early dinosaurs, if they'd have had telescopes, and they may well not have seen the planet with rings. So the most, as far as I'm aware, the most likely explanation now is that a moon was deflected inwards towards the planet, an icy moon, and broke up because of the gravitational forces, the so-called tidal forces, when you get a moon very close to a planet. And so broke up, and then the fragments of that moon became distributed around the planet relatively recent. And I'm talking about perhaps tens of millions of years. So not tremendously long time periods. And that's an explanation for why they're very shiny. Another explanation, which used to be favoured, I don't think is now, is just that you get a lot of collisions in the rings between the crystals, and so they're self-cleaning in a sense, because the icy fragments bump into each other and shear off, revealing their reflective faces. But I think the best explanation probably is that they're young, and it's quite a nice explanation because it means that we are in a very fortunate era, probably only tens of millions of years long, when we can see those beautiful rings.
I love the idea of dinosaur telescopes. I hope you've got one in dry store number 1 at the Natural History Museum, Miranda. I hope, because it's very specific design for the T-Rex, isn't it, to make it workable?
Indeed. Yeah. You'd have to come and investigate my cabinet for curiosities and find that.
But you do get lenses in trilobite eyes, right? There are fossils where you do actually have lenses in their eyes that you could presumably turn into a telescope if you really wanted. I mean, the trilobites might not have done it, but the crystals are there.
Well, while we're on kind of life generally, there are many complex organisms. This is from Steve Zara. Many complex organisms that live close to volcanic vents, worms, crabs, mollusks, etc. What is the hottest temperature that these complex organisms can live in? Now, has anyone like to take that? Brian, it's the kind of place you go to all the time, isn't it? All those, vents. I do love hanging around the vent.
I did get to go. Has anyone else ever visited one? I got to go in Alvin, down to the just off the coast of
Lucky you. I haven't been in Alvin, but part of the reason it's a really difficult question to answer is that the reason there's life at those vents is there's a temperature gradient. So the water that is coming out of the vent could be 400 degrees. The pressure is what keeps it liquid. And the reason that it's such a fertile place for life, and the reason it's so hard to study, is that you can go from 400 degrees to perhaps 10 degrees over a few centimeters. So the organisms that live there, quite a lot of the ones that are deep inside, basically have one side that is on the hot. It's like having your back to the fire. And so one of the interesting things is actually, I think, less about the temperature itself. I don't know the actual number, but it's the ability to survive that tremendous temperature gradient across their body and not survive. But that's the reason it's also difficult to measure the actual temperature they live at, because where exactly in the gradient were they? Where it's like a super, super steep hill. If you go a little bit to the left, you go up quite a lot. So I don't know the answer, but I do think that the temperature gradient is much more of a puzzle in some senses than the temperature itself.
This is from Frey, who's age 15, and from his or her brother, age 6. My little brother wants to know what started gravity, and I would quite like to know where gamma radiation comes from. So it's a double whammy there. The idea of gravity starts. So where does that? I mean, because that is the incredible thing that Brian Greene's book, as I mentioned, Brian Greene will be on next week in his new book. It's a very beautiful book about what is required for there to be a universe such as ours, which we are able to live in, and that point in which there appears to be nothing, and then the universe begins, and then gravity. When do we observe gravity, Brian?
Well, so gravity, it's one of those properties of the universe that we take as what you might call an axiom. So there are if everything in nature were derivable, so you could somehow explain where gravity comes from, then you'd be able to derive the universe as it is, right? So what our best model of gravity at the moment is Einstein's theory of general relativity, which says gravity is essentially, going to Brian Greene's book, the curvature of the fabric of the universe. So you can imagine, we call it space-time, but you can imagine the universe is, it's often referred to as a fabric, and the presence of anything in that fabric, matter, energy, anything at all, curves it and distorts it. And what we see as the force of gravity, or feel as the force of gravity, is the response of everything else in the universe, including ourselves, to that curvature and distortion of the fabric of the universe itself, space-time. And if you ask why, then our answer is, at the moment, because that's the way that nature is. So we don't know whether space-time itself, whether this fabric is some kind of property that emerges from a deeper theory. There are people working on this. Sean Carroll's latest book, actually, which is a wonderful book, whose name I forgot. You'll remember it, Robin. What's it called? The latest one. It's a great Einstein quote about something deeply hidden. Something deeply hidden. So in the last chapter, there's a good description of what people are. Space and time. Remember, when I say space-time, I'm talking about space and time merged together. So we're saying, can you derive what time is and what space is and how they're merged together in a deeper theory? There are people trying to do that from quantum theory. No consensus right at the beginning of that journey. So at the moment, the answer to that question, as with many things, like what is the origin of matter, these kind of questions, ultimately there's a lot of we don't know. That is it is an observation we make of nature, and there is no deeper understanding of what those things are yet, if ever, and that's the answer.
Thank you so much. We've run out of time, and I'll just mention, Brian should be back with us on Tuesday morning at 10 a.m. Also with David McColmont and Beck Hill. And we thank you so much, Helen. Thank you so much, Miranda. Thank you, Brian. Because I don't know you also had such a struggle with all of that.
I would have liked to talk to you both, and we could have answered questions together. But obviously, I'm useless, or some things useless in my technology. But it's solved now.
Well, we're all going to be at home for a long time, so there might be an opportunity.
We'll all stay in contact, and thank you so much, everyone who's watched. Do remind you, go to cosmicshambles.com, where you can find all the stuff that we've got coming up on the Stay at Home thing tomorrow night. Tomorrow night or tomorrow morning, I can't remember which. Actually, Josie Long is going to be presenting some of the things that would have been at the Melbourne Comedy Festival, which has obviously been cancelled. It's tomorrow night. I've just had a little signal on that, and so go to cosmicshambles.com, find out what we're we're doing. As I said, any money that we make from this is going to go to some of the people that we know and some of the people who got in contact with us who are going to really struggle because all of that work has disappeared at the moment, and also to try and keep some of the venues going. And we will keep you up to date with where that stuff is going. So if you can go to the tip thing, that is brilliant. On Cosmic Shambles as well, we have a new episode of Book Shambles up at the moment with the brilliant Tracy Thorne talking about many different things. I'll also just briefly mention, I'm sure everyone watching this is already being sensible, but really do take social distancing very, very seriously. I've been talking to nurses, I've been talking to doctors, I've been talking about their worries and their very, very big worries of what they're going to have to deal with, and be kind to people. You know, this is the great Kurt Vonnegut line, and it's so important, which is, you know, if you had one piece of advice for all the babies of the world that were going to grow up to be 100 years old, that is, God damn it, you've got to be kind. Thank you so much for watching. And
can I just interrupt? It's a beautiful, beautiful thing, but I love your headphones. You look like a kind of I don't know, like an agricultural Cyberman or something.
No, do you know what it is?
Like a Cyberman who works in the fields.
They're my son's Minecraft headphones. They're my son's Minecraft headphones.
Excuses.
I like them.
There you go.
Do you know what? In the partnership with Brian, I've never been the one for sartorial elegance, not even with headphones. See you all soon.